to this Friday afternoon at Harvard Law West and the Computer Graphics and Visualization Speaker Series. I'm William Barrows, one of the co-organizers, along with Brent Mason and Tony LeClaire in the Computer Science Department. We all generally specialize in computer graphics as our area of interest. Today we have Brent Mason, who comes to us from actually just across the bridge in Mount Pleasant, but he works for NaturalPoint, which is a company that is located in Corvallis, Oregon. NaturalPoint is currently the world's biggest seller in terms of volume of motion tracking equipment, and Brent will be able to tell us about all the different applications. Brent also has a background of working with the movie industry in Hollywood, and he can tell us some interesting stories. So Brent will be giving us sort of an overview of mocap and what it can be used for. And you'll get a chance to play with some of the equipment and walk around with some of these reflective marker dots that are controlling animations on the screen. So here is Brent Mason.
Thanks. Thanks for coming out. So I work for a company called NaturalPoint. We're based out of Corvallis, Oregon. Corvallis is about an hour and a half south of Portland, and it's where Oregon State University is. So our company is a motion capture company. We make hardware and software for different applications. Our biggest application by far is definitely the entertainment industry. So I figured I would kind of give you guys a rundown or an overview of the different applications that use motion capture, and a little bit about my background, show you some customer videos, and then walk you through our software and do a little virtual camera streaming demonstration. So my background is, when I was in university, I had no idea what I was going to study. So I was one of those kids growing up who took apart his family's computers and VCRs and phones and stuff like that. And I was also into art as well. So kind of a mixture of technology and art growing up, and just had no idea what I was going to study in college. So I decided to study film and photography. So after college, I went, I had no idea what I was going to do, trying to put off the real world for a little while. So I went and did an unpaid internship at a place called the International Film and Photography Workshops in Rockport and Camden, Maine. And I was going to show you guys kind of what this place is all about. They're now called the Maine Media Workshops, but it's a cool place to go. During the summer, they have classes where you can go take, 1-2 week courses on filmmaking, lighting, cinematography, editing, all sorts of things. So I went there after college, interned for a few months. The program was ending, and a movie was coming through town. So I knew that I wanted to work on films in some way. So I went over to the production offices that were in Maine for this film. It wound up being an HBO movie that had Ed Harris, Paul Newman, Philip Seymour Hoffman, Helen Hunt, pretty big cast, called Empire Falls. And it was just like a 2 or 3 part series on HBO. So I went over, got connected with the sound department, the video department, and did another unpaid internship for another few months. So, it was like living out of my car and at hotels whenever the production would could afford to let me do that. And then they would pay me from time to time when as a production assistant or a stand-in for one of the actors. So it was a great experience, got to meet a lot of people, and then when that was over, it was kind of, all right, ready for the real world. What am I going to do? So I did what any college student who has an art degree and just did 6 months of unpaid internship should do, and packed up my car and drove to LA, and got to start working in the film business. So I was very fortunate. The contacts that I made from the workshops and from the film that I worked on allowed me to start working in the film business. So people started giving me jobs, fortunately. And the jobs that I started doing were as a digital imaging technician or reference video operator. So the idea being, before all the digital cinema cameras started being released, everybody was still shooting on film. There'd be a video tap on the film cameras where you would either wirelessly or through a long cable connect to a computer card, which is essentially just a glorified DVR. So every take, every shot that's happening, we're recording onto hard drives on a computer to be able to play back in real time for directors, cinematographers, and actors on set, and producers. So that's what I started doing and had a great time with it. Got to work on some really nice projects. And while doing that, I started working in the motion capture industry. So there's a lot of video games and visual effects for feature films, animated features, started shooting motion capture like a film. So I had some good connections who hooked me up with a motion capture stage, a studio that would have anybody who wanted to come shoot could come there, rent the stage out. They'd hire actors, do everything from just body data, capturing horses, capturing face data, audio, reference video, anything to make it more like a professional film set. So I was fortunate, kind of got in at the beginning of, I would say kind of the beginning when people started using motion capture for video games, and my responsibility on set was usually to be the video engineer. So if they're shooting cinematics for a video game, then they need to have the performers, different angles, wide shots, medium shots, close-up shots, just depending on what the director or cinematographer is looking for. And then they would essentially cut the footage that we shot down into a little film or the cinematics for the game, so they could then go into the 3D program like Motion Builder or Maya and decide where they're going to put these virtual cameras within those scenes. So it was really great experience getting to do that, and that's how I started to learn motion capture, just being there on set. I had no idea what it was. All these cameras around the space and people in these pretty skin-tight suits with these markers on them. I had no idea what it was, so I just started learning the technology, and then when there would be shoots where it wouldn't require cinematics or the kind of big video camera setup, then they would have me come on as like a production assistant to do calibrations, do on-set quality control, help actors out, things like that. So just to show you guys some of like bigger sets that are out there. I got to work on a couple of pretty big projects, which were sorry, let me just try to find some stuff here. So this was a film called Mars Needs Moms, which was shot at a company called Image Movers Digital. So the company that I was working for sold a big camera system to this company, and they needed someone to be kind of the on-set liaison between our company and the company that was shooting this film. So I got to be there on set every day, just making sure that all the technology was working right, and if anything happened during the shoot, I would have to kind of try to do troubleshooting on the fly, which can be very stressful when there's 200 crew members all waiting on you to figure out why a camera system isn't working. So this was Mars Needs Moms. I also got to work on A Christmas Carol, which was a Jim Carrey film. So let's just see. I had this set up as... So I don't know if you guys have seen this film, but I was just going to show the trailer here, maybe, just so you can get an idea of what...
You didn't eat your broccoli.
I don't know if you guys can hear this or not, probably not.
Milo, that broccoli.
No, that's vomit, but I understand the confusion.
I told you to eat that.
You're not gonna make me eat it now, are you? Wasn't a good thing to say. I'm gonna go tell her I'm sorry. Mom? Let her go!
So it's just an example of different, well, this particular movie, but of different shots that we can shoot, right? So there's some pretty standard shots, standard movements, and then a lot of kind of, I'd say, high action stuff. So like this company had a really big wire rig setup, so they could do some really big stunts. But kind of gives you an idea of the kind of shots that we would capture for motion capture, and then how they translate into a feature.
I'm just trying to find my mom. She's the one that vacuums the house. Oh, come on.
Right, so it's just an example. So you can see the size of the space that they use for something like this. On this production, they were doing face capture as well. So they'd have a bunch of high contrast dots on a person's face, and then helmet camera to capture the markers on their face. And then there's some pretty big wire rigs set up to do those really exaggerated moves. So they could do that in post-production for the animation, or they could do it, actually capture it and say everything was captured a specific way. All right. This is another, shoot, nope. Must have gone to another video. That's all right. So let's see, and some other examples of what it's like on set I was going to show you. So I did, the first stuff that I really worked on in the gaming side was Uncharted, which is a big PlayStation release. It's a big series now. So I think they're about to release the 4th version of the game. And this is just to give you an idea of what it's like, right? So we have reference video cameras on set. So we're shooting the action from different angles so that they can take that, edit it, and figure out what the cameras are going to look like, right? So you can see what the shoot was, what a rough animation looks like, and then the final animation, the way that they cut the shots around. So I can move forward here. I'm sure the internet's a little slow. Maybe not. Well, let's see if it comes back. All right, so this is how I learned motion capture, was on set doing stuff like this. So, working in the film business, it was, we quite often do like 12 to 16-hour days, and it gets, you can get kind of burnt out. So when Image Movers Digital bought a system, some of our support guys went over to work there. So I took a full-time job, started out doing support for a motion capture company. So I would go out, do on-site installations, trainings, demos, trade shows, things like that, for other customers. So it's a great way to really learn how customers are using the technology and helping them develop their internal pipelines. So it's awesome to work on these big productions, but they can be pretty stressful, pretty long hours. You might work for a few months straight every day, 12, 16-hour days with like 8-hour turnaround. So it can be pretty exhausting. So I kind of just wanted to try something else out, and so I took this support role at the main company who owned the studio. So, go out, do a lot of travel, help visual effects companies, gaming studios figure out exactly what they need for their different applications, mostly on the animation side. So I think that shows what I wanted to show there. All right, so I wanted to kind of give you guys an overview of some of the different applications, right? So some of our customers on the entertainment side, we have service studios who are using our equipment. So these are studios who buy a system and they get other companies to come in to like rent the stage or lease the stage. This is a company called Animatrix. They're doing some really big things right now. This is a guy who used to work at the company that I previously worked for, and he kind of went off on his own, went to work for a company called Autodesk to do some virtual camera stuff, and then he opened up his own company and has been doing amazing projects. So he started out doing visual effects on District 9, went on to do Elysium, Warm Bodies. You can see some of the stuff that they're doing. And see kind of what their stage looks like here. So, you know, right now these guys are shooting the live action Jungle Book film, and I think that they helped out with the new World of Warcraft film that's coming out, I think, next year. So just a giant space that allows you to have a ton of performers out in the space at one time, capturing data, different moves. Right, that's one good example. This is another one, Game On Audio. These guys did, they have a huge space up in Montreal. They did, let's see, like this game called Thief. Can just let some of this stuff play, maybe. It's gonna be fast enough. But so these guys, it's same thing. They're a service studio, right? They have customers come in, shoot at their stage. They do a lot of the animation, the data cleanup, and hand it back over to their customers. Sorry, this is not playing. But you can see kind of the size of their space. This is what the markers look like on a person's body. You can have different patches to help, you know, maybe the motion capture operator determine which performer they're looking at. Just by the color of the patches on their marker on their body. So these guys are doing head cameras as well. They have props, different set pieces that they interact with out in the space. So you know, on the entertainment side, all the different entertainment stuff is pretty much the same. It's visual. It's capturing moves that are going to be applied to some CG character in another piece of software for a game, for a movie, for an animated film. And to show you another example of that, I was going to play this. It's called Construct. This is just a teaser trailer for something one of our customers has been working on. And this is a really good example of motion capture and virtual cameras used at the same time. All right, so it's someone. This is someone who is in a motion capture suit, and that animation that they capture is pushed out to another 3D program that's driving this CG character. So that's a cool little trailer from a customer. Right. So some of the other applications that we deal with are like on the biomechanics side. So we have a lot of life science customers who are doing different studies to help people move. So it could be on the athletic side, so sports trainers are using systems to study the way, say, a pitcher throws a baseball or hits a golf ball or passes a football, whatever the case may be, to see the way that their body is moving and offer advice on, hey, if you move your body this way or rotate your arm this way, you'll be able to save your arm from, say, getting out, or like if you're a pitcher, right? It'll save you from having to retire a few years early. So you can reduce the risk of injury, improve performance on the sports side. One of our big customers is the Ohio State University Spine Research Institute. So they do a lot of things like disorder prevention, where they're doing risk exposure quantification. So they'll have people come in, like one of their customers is Coca-Cola. So right now they're doing a study where Coca-Cola wants to know, hey, what happens to our workers' backs when they're moving around those giant vending machines, the double wide ones or the single wide ones. So they'll take those machines, put them on the dollies, and have a person in a motion capture suit move those Coke machines around a space, and then do studies on what's happening with the person's spine. So they can say, hey, this person is most likely to injure their back during moving these machines around. This person has a strong back and probably won't have any issues for a number of years. And then they can do kind of, I guess I would call it like base testing, where if you're going to come in to do a job, say like on a loading dock, where your job is to, maybe you're at a grocery store or at Lowe's or something, your job is to pick up crates or boxes off the back of a shipping truck and move them into the warehouse. So they'll do studies to see how are you moving when you first start the job, and then how are you moving, say, 6 months after or 2 years after. So that way, if someone gets injured on the job, they can look at what your original baseline was. They can look at what your back is doing however much longer into the job or career, and they can say, your back is degrading. You have a higher chance of getting injured. Or if they do get injured, they can do tests to see, well, is this person faking their injury? Or is this person actually injured? And then give that information to a doctor or whoever would be diagnosing whatever's wrong with them, so that they can say, well, this is the best course of action for getting back on track, getting your injury healed properly, and getting back to work. So they do a lot of stuff like that. And a good example of that is they have the Center for Occupational Health and Automotive Manufacturing, right? So this is a lab, I think it was donated by Honda maybe. So Honda has a big factory in Ohio close to Ohio State University. So Honda asked this Spine Research Institute to look at the way the people on their assembly line are working. So as a car moves down the assembly line, how does that car need to be rotated on this giant rig so that people on the assembly line can do their jobs and not get injured, or be less likely to get injured? Because if you get injured on an assembly line, the whole thing has to shut down, and the assembly line might be down for an hour or a few hours, which could cause a lot of delays. So they were able to do studies in-house at Ohio State and determine what the best positioning is for cars as it goes down the assembly line, so that and they were able to reduce injuries by something like 90%, something like that. So there are a lot of different applications on the life science side, biomechanics side for studies on motion capture. Let's see, this is another one. This is a Barcelona tech who does biomechanics. So they capture analysis of human movement, gait analysis. So just different studies. There might be a person coming back from war who's had their leg shot off or something. They're getting fitted for a prosthetic limb. So things like that. How is this person's gait affecting the rest of their body, the way that they move? What's the best prosthetic limb that's going to fit them? What are the right measurements for it so that they don't injure their back or injure some other part of their body with the wrong size of a limb? Let's see. So some other customers. Let me see if I've got examples of some videos here. Those are more entertainment based. This is another. So beyond biomech, we have a lot of VR applications. A lot of customers doing virtual reality. So this could be engineering. It could be entertainment based. Simulation training. So this is one where Framestore, which is a pretty big visual effects company, most of their VFX work is done in London, I think. They also have an advertising agency in New York. So these guys got a system to track the position and orientation of a head mount display like an Oculus as a person is walking through a space. So they develop these kind of cool virtual reality experiences for their customers. So this is one where Merrill took this, they call it an immersive virtual hike. So I don't know if this is going to show up well. You might get kind of a sense for what they're doing, right? So they've got a helmet on, they've got the display on, and then they've got markers on top of it that they're tracking. Right, so a person is walking through kind of a narrow space, right? They're looking around, you can see the trail, and there's rocks falling, different things like that. So as you walk and move through the space, you're just completely immersed in this world. And they may have even built like an actual like wooden swinging bridge for the participants to walk across. So there's a lot of cool virtual reality kind of art experiences like this as well that people are doing. And another part of the virtual reality side is cave environments. So we have a lot of customers who, they might have kind of really small rooms, like 10 foot by 10 foot, where they'll call it a 4-wall cave. So it'll be right in front of you, a wall on each side, and then the floor. So you'll have these 3D glasses on that are shuttered, active 3D glasses. So as you look around, instead of seeing seams like on where the wall and the corners of the room are, you're just looking out into this just giant space. So this is an example of this immersive virtual reality technology from one of our customers called Eon Reality. So you can kind of get an idea of what. Let's try this again. Maybe. Right, so this one the guy's got a controller, something like that. This is an Xbox wireless controller that I'm going to set up as a virtual camera. But you can take it, you can grab objects, move them around in the space, kind of interact with different things. So we have customers all over the board using or doing stuff like this. It might be military training simulation applications where they're trying to like land a helicopter on an oil rig out in the ocean, or interact with internal organs, move them around and see maybe what the flow of the blood is through your body, or take components apart like this. Then we have like on the also on the engineering side, we have customers doing a lot of like virtual environments like this, where maybe it's like Ford is one of our customers. So they want to know when you sit down in a car, what does it feel like? So instead of building a whole car every time that they want someone to see what it feels like, they do it virtually. So it saves a lot of time and a lot of money, so they can very quickly tweak things so that you can have this virtual experience to get a feel for where things are in the car. So it's kind of along the same lines as this. So it's hard to get a sense for what's actually going on, because it's just everything looks flat right here. But when you're actually looking around the space, it all looks very seamless. All right. So I wanted to show what some of our customers are doing too. This is a really good video that. All right, so this is kind of cool. This is the mixing technology and art for kind of. I don't know. I think maybe these guys just made this video to show what they can do, but there's a lot of people doing this stuff kind of like, I would say, in real time, and I'll show you an application of that. But so this is projection mapping, 3D projection mapping onto people's faces. So they have some of our retroreflective markers on their faces, streaming into a third-party software. So as these people move their heads around, the projector is the image on the projector is following what their faces are doing. All right, so I'll just let this play. This one's kind of cool. So you can see the little markers on their face. They're either flat discs or hemispheres. So what our cameras are doing is they're tracking the position and orientation of these guys' heads. So you can see these guys are just sitting there with their mouths closed, their eyes closed, and as they move around, the images follow their faces. So their heads are set up as rigid bodies, right? There's markers on their forehead, nose, cheeks, chin. So our technology will allow you to get the position and orientation of objects out in space. So something like this, there's potential for, I don't know, I would say on the consumer side, for even say like makeup companies or Halloween costume companies. What would I look like if I had my face painted a certain way? Or what would it look like if I had a certain makeup style on my face? So this projection mapping application is pretty popular right now. So there's a lot of ad agencies and artists doing this stuff, and this is kind of cool. It's like one of those flip books where you could change eyes and nose and mouth. And I have a customer right now they're going to try to do this on a full body suit. So it'll be someone in basically a skin tight white suit with markers on them doing projection mapping like this over the whole body, which should be pretty interesting to see. All right, I think you guys get the point. And then on the same note, this is another company called, I think they're VYV. So they do a lot of live stage stuff. So this is for this Miley Cyrus tour this last year. So with their technology, they're doing projection mapping on some of these giant, like, inflatable objects that the performers interact with out on stage. And this guy right now, he's holding up this device, and it's actually an LED. So the lights are mounted on these pan tilt heads. So our motion capture cameras are tracking the position of that LED out in space, and the lights are then following that LED. So it helps to not have, like, somebody up at the, up in the lighting grid following a person around, right? So it helps to, get rid of having to pay someone to do that, and then also more accurately, I would say, track a person around the stage. I imagine it's pretty intense to move a light around for a couple-hour show. So we have a lot of different customers doing stuff. So this is the projection mapping on that giant inflatable cat thing. Right. And then, so we also have customers who use our technology for like ground truth systems. So one of our customers is Microsoft. So they, they have the Kinect, which is a depth sensing camera, and so you can go up. Some people use it as a motion capture system. With the Xbox games, you can kind of drive characters as you play the games. And this kind of showcases their technology and how they use our system as like a ground truth for what the person is actually doing. So it's cool to see customers who have similar technology using our technology. Anyway, I'm sure you guys are familiar with the Kinect. But I was going to also show you, this is a company called KML Robotics, who they make quad rotors. And they partnered with Lexus to do a cool little commercial with these small quad rotors interacting with different environments. So I'll play this one. This one's kind of fun. Right, so we've got 4 markers on the top of each of these quad rotors, flying them around through different environments, a grocery store, a museum. So on the engineering side, right, these guys programmed, wrote a program so they know where the position and orientation of each one of these objects is out in space, and they can tell it then where to be. So we have a lot of customers doing things like this on the UAV side. So this is a big application right now. On the military side, and then just the companies, obviously we didn't shoot hundreds of these things flying around a city, just the ground stuff. But it's kind of cool to see how they do it. So. Right, this is one where they actually talk about coding the stuff, how they did this.
We've done a lot of work on these vehicles over the year to make them fly, to show off this idea of creating something that's amazing in motion.
One of the great technical challenges of the job was taking technology that had previously only really worked in an engineering setting, in a studio setting, into real public places. That's a massive thing for Lexus and a huge part of this project. There was an awful lot of development, research, trial and error involved in trying to get the quad rotors to fly in this very precise way and to interact with everyday objects and everyday spaces.
All right, so we showed something similar at a trade show recently, just having quad rotors flying around a space and just being programmed to kind of do figure eights around a couple of light stands like this. But it's, you know, they're doing some really cool things. There's, I don't know if you've seen the ones, these guys also did, and I don't have the videos with me, but they did some music ones where they've got the quad rotors playing different songs. I think there's a cool James Bond one where they're playing the James Bond theme song as well. So let's see. So I think that's all the video stuff I was going to show for the presentation. And I was going to kind of tell you guys about our technology now, right? So we make these motion capture cameras, the hardware and the software, all in our Oregon office. So the way that the cameras work is there's a lens, there's a sensor, and there's a ring of LEDs. So the LEDs emit a specific wavelength of light. They're 850 nanometers. The light emits at a specific frame rate. So we've got cameras that go up to that are different resolutions and can capture at different frame rates. So these are called our Prime 13W. They do up to 240 frames per second, which is pretty fast. The light emits from the LEDs, hits these retroreflective markers, and the light bounces back to the light source. So because the LEDs are around the lens picks up each of these markers. So there's processors on each of the cameras that will look at these kind of groups of markers and say, hey, how bright is that? How circular is that? Can I fit a circle around it, find the center of that, and send that centroid information back to the software? So the cameras are calibrated, so the software knows where they are in relation to one another, and we do that with this calibration wand. So we do a dynamic calibration where we wave this around the space, and maybe I can, if anybody really wants to see that part, can stay after and I can show you. So we wave this around the space. I try to cover the camera's sensor top to bottom, left to right, front to back. And then we set the origin of the world space, so the 0, 0, 0 of the space, using this calibration tool. So we've got Z going one way, X going another way, Y pointing up. I set this out on the ground, and that will set the origin. So then our software knows the position or position of any marker that's out in that defined space. Or if there are 3 markers associated to an object, like these two, then we can get 6 degrees of freedom information from those rigid bodies. And we can also, our software has built-in models for capturing full body data. Right, so this is just showing our camera lineup. We've got some entry-level USB-based cameras that range from $600 to $1,000 each, and then we have our kind of our Ethernet-based cameras, which are a little bit higher resolution, can see further away, so they they range from $2,000 to $6,000 a piece. And then we have some other pre-calibrated duo and trio. So these are 2 or 3 cameras together in a little bar for doing tracking like this. And then we have, bring open. We have a virtual camera system as well. So this is something that I've just got an Xbox controller to show you guys, but this is something where the cinematographer on the game or the visual effects shoot would be able to use this to actually peer into the virtual world that they are creating these motions for. And I'll show you guys that here in a minute. Right, so I had a PowerPoint presentation. Haven't haven't really been going by it. I guess I could tell you guys a little bit about, so this is a passive optical motion capture system, right? We have some different competitors who have different technologies. So there's a markerless system. So that's what this guy is here. You can see that they're people just kind of in plain clothes, and they're in a high contrast environment. So there are, I would say, limitations to that kind of a setup where you can only have maybe up to 4 people and in a space that's about 20 by 20, something like that. So it's not very scalable, and those systems tend to break apart when you put your arms close to your body or people's bodies get close together. Just because they're essentially just looking at the high contrast, a dark image over a very white, bright background. So those setups require like a special fabric around the space, on the floor, and lighting to really light up the scene. Then there's stuff like the Kinect, which does depth sensing. I've seen people do a few of these together to make a larger space, but they're very limited as to what they can do and how you can set them up. There are inertial suits, so these are little like a battery-powered inertial sensors that are placed on the body that each can report 6DoF information, and they connect to a battery pack or have batteries individually, and then go out to like another Wi-Fi or Bluetooth hub, something like that. Those tend to not be as accurate as our systems too, and there tends to be drift with them. So the longer it takes, maybe the further away from the origin you might wind up. And then there are active LED markers. So it's the same idea sort of as what we have, whereas instead of the LEDs being on the cameras, the LEDs are on, like these would be the LEDs instead of the passive markers. So this just shows some examples of those, each of those. And then I talked about different applications, motion capture applications. On the entertainment side, I said, VFX and films, TV shows, commercials. There's a lot of different applications as well, besides just capturing body data. So a lot of customers will use it for pre-visualization and virtual cameras. So a good example of this is someone like DreamWorks. They have a motion capture system, so they will have their animators come down to their motion capture room, get in the suit, and kind of become the character that they're trying to animate. So if they've got Shrek or one of the How to Train Your Dragon characters, or or a new character that they're trying to create, you might have a bunch of different people on the development team trying to figure out what this character's personality should be, and it can help to get somebody into a motion capture suit and get them moving around to get a better idea of what that character should be and how they should perform. And it's a way to quickly get through shots too. It might take someone a week to get through animating a shot that you could do in a few minutes with a motion capture system. So you can get more shots out very quickly, whether it's for actually to put in a feature or a game, or to just give you as reference for when you're going to animate. So we have some customers who don't want to use motion capture, but will use it as reference instead of having it in the actual their actual end product. Or some people who just want to get it, they have 10 ideas, they want to capture all of them, and then pick out later in a review session which one is going to be best for maybe dramatic effect or comedic timing, something like that. So a lot of different ways to use it. This is just showing the camera line up, some of the way that the cameras work, the technology works, right? So here are the LEDs, the lens. Depending on which camera model we can give you focus, aperture control. So on the cameras, they also have filters to block out other wavelengths of light besides the wavelength that is on the LEDs. And then we have the ability to turn our cameras into reference video cameras as well. So during productions or life science applications, whatever it is, customers might want the 3D information that they're capturing, but also want to have some sort of reference video to look at. So any of our cameras can be turned into a reference video, which is a nice feature. So let me just jump over to the software. How are we doing on time? I have no idea what. Right, so this is our software. It's called Motive, and this is a version called Motive Body that gives us access to capture body data. So these are the cameras that you see right here. See, I can select them. I know which one I've selected because it turns yellow by the status indicator LED ring, and then I've got the origin here, so you can see where the Z and X come together. This is where I had set the origin using this calibration tool. So I was going to show you guys a virtual camera. Right, so I don't know how well you guys can see this, right? But you can see it's called Rigid Body 1. We're tracking position and orientation of this object out in this space. So if I click on this guy, I can get the real-time information. So I can see what it's doing even as it's just sitting there. So our systems are sub-millimeter accurate. So you can see as it's sitting there, not doing anything, you can look at the position data and see that it's, those changes that are happening are less than 1 millimeter. All right. So what we do is to track a rigid body, we'll put markers on an object in an asymmetrical pattern. Then in the software we can select those markers and then select an option to create a rigid body. So from there we can go and start streaming the data out or capturing takes. On the body side we have template files. So let me just choose one here, right? So this is nice. It gives you kind of this 3D character that you can zoom in and on and move around to see where the markers go on the person's body. I think I had a picture of that here. All right, well, I can just show you this in the software. So in the software I can see the 2D camera views and I can see the 3D view. So these are the markers that are on that virtual camera controller. All right, so we're tracking the position, the XY position of each one of these markers. All right, so you can see the position here on this camera, and then it's processing that on board the camera, sending it back to the software, so we can then get the XYZ coordinates of those markers out in space. So if I just go offline, I'll show you what a typical setup looks like, right? So this is I think this was a 12 or you can just look here, 12 camera system that I did a short capture for, set up. Got 8 cameras up high, 4 down low. We usually keep the cameras spread out pretty evenly around the perimeter of a room. So at least 2 cameras have to overlap fields of view in order to reconstruct in 3D one of these retroreflective markers. So in general, let's say we had a 30 by 30 foot room, the camera overlap for full body data is around 7 feet from the cameras. So we would have about like a 16 by 16, just depending on which camera model. and the size of the room would depend on the size of the capture space. So this one I've got cameras up high and some cameras down low, and you can kind of see what the data looks like. So what we do to do a character calibration, we have the person stand out in a T-pose. So their feet are shoulder width apart, facing forward, hands are palms down, and then we do click a button and it's able to fit this skeleton within this marker cloud. So in this one, it's just this is a shot where a guy is a little. This is for a little game. It's of a guy who's running down a path, and he's got a gun, and he's kind of shooting at different people, or shooting at something up high, ducking behind a tree, and then coming over, kind of crouching a little bit, shooting again. So we just did this like a few times, so I can kind of scrub through the take. I can play it back, slow, fast, backwards, whatever. So this is what the data looks like in 3D, and we take this information and push it off to some sort of CG character, whether it's a zombie or a soldier or whatever, so that it saves animators time from having to keyframe animate. All right, and then let me go back live here. All right, so right now I'm streaming this real time out to a third-party program called Motion Builder. So Motion Builder is an animation package from Autodesk, and I wanted to show you guys some motion capture data driving a character, and in this case I just had 4 different characters, and it's the same animation driving each of the characters, and it's going to be a similar run, like a path where they're running down with a gun and they crouch down and shoot a little bit, which has nothing to do with this scene. This is just that's all I had. All right. All right, so try to make this full screen here. All right, so this is the virtual camera hooked up. So, all right, this gives you an idea. I can zoom in. If I were, a virtual cinematographer or whatever, I can walk around the space. I can record shots and play them back. So a big production might have something like this where they are doing this all in real time on set. Or they'll take the animation that they've already captured and play it back and do their camera passes this way. Right, so all my cameras are kind of facing this way, so I won't have as good of coverage going backwards, just depending on how I'm facing. So this is kind of fun to do. I don't know, you can see videos online of how they did this in the Hobbit trilogy, but I can pan the camera up, tilt down, zoom in, zoom out. So we have a bunch of different controls here for this. So I guess I just played through one time. So anyway, that's what I was going to show. If anybody wants to play around with this, please feel free to. Does anyone have any questions about anything?
So these are standard body types. space people, right? That you have stored, that they wore the motion capture, they basically, what we're looking at are sort of prototypical body types, right?
Yeah, so what I've got here is these are characters that I created on a free website that was called Evolver. I don't think it exists anymore. Autodesk bought it and shut it down, and might have put it in their software, another piece of software. But just making some pretty standard characters that are already rigged that can be driven by motion capture data. So, you know, you guys might take animation classes or modeling classes or rigging classes to learn how to do all this stuff. And yeah, this is all pretty standard though. It was a person in a motion capture suit. We have I think our standard set is 41 markers maybe, or 43. So, you know, generally what happens on set for production is, you know what the shots are that you're going to be capturing, and you know who the performers are. So they come in at the beginning of the day, you do the calibration of the system, set everything up, and then you get the performers in their suits markered up, do their calibration process, and then you're ready to start capturing. So a lot of times on set, we might have a motion capture operator at one PC. This is Motion Builder. We have a Motion Builder operator on another PC, a quality control person at another PC. So, you know, this is helpful for directors on set. So if they're looking at what the final animation is going to be, this is a really good indication of what they're going to have. So, yeah, this is all pretty standard
I could
stuff.
see capturing at a, you know, he had really high frame rates there for capturing position data. I mean, why is he maybe 2 or 3 times a 24 frame per second frame rate? Why do I need it at 240 or something like that?
Yeah, that's a good question. So we do a much higher frame rate because of the post-processing side, and it depends on the application as well. So if we have customers on the robotics side doing UAV studies who every microsecond counts. So the less time there is between frames, the less latency, the better it is for them when they're tracking a UAV flying through a space, and it needs to determine its position and orientation to know, hey, I know that I can't go beyond these bounds, otherwise I'm going to crash into a wall. So that kind of timing helps, but then for, you know, generally for the animation side, we capture at 120 frames per second, and it's to help for post-processing. So if you've got markers that are, you know, moving through space like this, and one becomes occluded, and, you know, as it's going along becomes occluded and then comes back in, well, you've got a better chance of being able to fill the gap that is there with more frames to work with. So you know, there are different cleanup processes. Some people don't do any cleanup and they just record directly into Motion Builder and have files that they can start working with where their characters are already being driven. Other people are very into making sure every single gap on every frame is filled. So there are tools in the software that let you do gap filling and different fills, pattern fills, rigid fills, things like that.
Is the subsystem for the motion capture independent from the camera, and they're just sort of like metadata that gets tagged onto it, or how on your cameras? Is that independent? Is that intrinsically tied to the camera itself?
Yeah, so with these cameras, these are Ethernet-based cameras. They do have processors on board. The cameras are going by one cable to a PoE switch. So they're getting power from this switch that's sitting down here on the floor. And then, like, this is a Cisco hub that can hold 8 cameras, and then there's an uplink port that's going to my PC. So we have systems that have almost 200 cameras in them. Like Activision's one of our customers, and they've got about 200 of our 4.1 megapixel cameras. So the data that's coming back is just, and you can choose the amount of data sort of that's coming back. You can have the grayscale video, you can do the actual pixels from the markers, getting rid of everything else that's in the scene, or you can have the option to do a mode where it tries to send the least amount of information back to the computer as possible. So it says, hey, there's a blob of pixels. Let me.
But is it independent from the film? Is it a separate channel that's synchronized in time, or how you're getting two pieces of information coming out of that film, right? One is looking at the markers and recording positional data, and then the film, the camera itself, I shouldn't say film, is actually recording some digital image.
Yeah.
Are those two separate channels, or are you interleaving those? Is it metadata that gets tacked on there? Or?
So we're recording each camera individually, which is what I'm showing here. So there's 4 separate cameras. They're all frame synced, so they're all exposing frames at the same time and saving a 2D file, what we call a 2D file. So it's the 2D information from each of those cameras. And then we also have the ability to record. So when you record a file, you're always recording the 2D information from the cameras. And yes, there is some metadata there to know which camera is which, the serial number, the exposure, some of the different camera values for each of those, each camera. And then you have the ability to also record 3D as well. So that's what we would be recording here in the Right, so it's what we'd be recording if we were recording this. So all the 3D position information of each of the markers. So there's 2D and there's 3D, and also you can independently, reconstruct the 2D information into 3D information. So we give you access to how this 2D information is going to be created as 3D information. So how many of these cameras need to be able to see one of these markers at a time in order to get the 3D position of it? Is it 2? Is it 3? Is it 4? So that you can go in after the fact and make changes to the data that you've captured. Did that answer your question?
Well, I guess just on the individual camera, you have these CCDs that are giving you an image.
Mm-hmm.
Camera itself. And then you have this positioning system that, what I was curious about is that independent of the actual CCD system for the camera, in which you've got 2 different channels. One that's capturing positions that you can sort of reference on the 2D image that you're getting from the camera.
Mm-hmm.
Or is that just somehow completely integrated into the image that you're getting out of the CCD of the camera itself? I mean, I just didn't know if these were 2 independent systems that are being, synchronized and interleaved, and where they're how they're doing it, or is it just one system that somehow is doing all that?
Yeah. So on a camera. Per camera basis, they're all doing processing on their own of what they're seeing, and then the software is what's doing the 3D part of it.
Like if somebody were to just cut the line there and try to intercept the data coming out of it, right? What would they see? They see the CCD normal data that you get out of a normal camera, right? And then there's other information keeping track of the positions of these things that are there. How would that information be interleaved into all that? I mean, is it a separate channel? Is it superimposed in some sense, encoded into the 2D frames that are flying across?
Yes.
I mean, that doesn't really matter. I mean, it's probably too detailed here. If they were 2 independent subsystems, and then when it gets to the software, it interleaves it, it fuses it right at that point.
Yes.
Camera and
No, it's the 2D information is all sent to the software, and then that's where all the combining of the separate cameras is done. But so we do have a camera SDK where you can just take one camera and get the XY coordinates out of a marker. So we have some customers who are doing laser tracking, like a company called Laser Shot, right? They're like a shooting simulation company. So they have a real gun with the barrel has a laser in it, and then the trigger is essentially like clicking of a mouse. So they'll point it at a screen. The camera will track the XY coordinates of that laser, and then when they pull the trigger, and for how long they had their hand on the trigger or whatever. So you could get that out, and then, but separately, if you're doing 3D, it's all just done right in Motive. But we do have an SDK for this, so you can stream this data out, like to Motion Builder or to some other program. So this is how, if you were, there's different game engines like Unity and Unreal, where you can have these whole virtual environments, kind of like Motion Builder here, where, if you're just tracking a person's head, you can get position orientation data. If you're doing full body, you can stream out joint angles as well. Time code.
Your virtual camera, is that a real-time thing? Like, can I in real time stick that virtual camera in and start moving around?
Yeah, yeah. So we could be capturing body data at the same time, and capture the virtual camera as well. So yeah, so we have customers who integrate with audio, like digital cinema cameras. So they'll do like live broadcasts. I don't know if you guys have seen the broadcast sets where it's just the whole thing is virtual and might be a crane coming down so that it changes perspective as the camera moves through or as it zooms in and out. It's the same idea as this. Yeah. So we can stream virtual cameras and body data all at the same time to different applications. Yeah.
So if a student had a script for a movie and they had to say 10 minutes and they wanted to capture the performance, how much time would it be involved in, say, actually capturing that down and tweaking it and touching it to get a polished 3D animated movie version of that? So it's not as simple as just putting on the suit, walking in, performing for 10 minutes, and you've got a perfect 3D animated movie.
Yeah.
Okay, so how much time is off behind the scenes generally goes into creating a polished product?
Yeah, well, I would say quite a bit of time. I guess it'd be hard to gauge a specific amount of time, but so a lot of people have this misconception that motion capture is just an end to the animation process completely. So we have a person usually start and stop a take in a T-pose so that an animator, when they're looking at a file, know, oh, this is when the take started, this is when it stopped, as opposed to just being mid-stride, walking around the space. So, generally if there's a script, there's already a breakdown of each scene or each shot within that scene, how it's going to play out and the dialogue that's going to be there or the action that's going to happen. So on a film, you've got different scenes and then different shots for each scene, because you've got, say, a wide shot and you've got a medium shot of one person and then another person and then maybe close-ups and maybe a turnaround of somebody else who's walking into the room. But with motion capture, you can capture all of that all at the same time, because it's just a matter of how you're going to position the virtual camera in post-processing. But I see people go from recording right into Motion Builder and having takes that they're just ready to start working with, to other people who take a really long time to get through stuff. But there's a lot of stuff to it. It's not just as easy as motion capture lets you just have a finished product. You have to have a modeled environment. You have to have modeled characters that are also rigged to be able to accept motion capture data, lighting, and then setting up the cameras within the environment to help determine what you're going to actually be seeing on the screen, or what your viewers are going to see, and then rendering that in some other piece of software. So it's the animation process in general is pretty involved. Yeah. What's that? Try to take it what? Oh, outside? Yeah, so you can use these camera systems outdoors, definitely, right? So the LEDs are 850 nanometer IR LEDs, and then there's a bandpass filter that's a very narrow filter to let in like 850 to 910 nanometer light. So when you take it outside, the worry is always with the sun. The more controlled the environment, the better. At night, you're fine. We've done like huge shoots outdoors at night, and there's really no issues. Assuming it's not like raining or snowing or something. Yes. Yeah. Yeah, so it just depends. If I've done setups where you're in between giant buildings and there's really no issues. But then I've done shoots on the top of a mountain where the sun is rising and just in the way the entire day. So it just depends on the environment. But you try to work around those things. I'll show you another example of this is a customer. Animatrix who's done a lot of pretty big features. So this is a commercial that they shot for. I'm not sure what company they were shooting this for. It's a like I guess pretty popular BMX guy riding around a track doing stunts. So we've got cameras pointing up directly at the sky. Generally, what we say is that the distance at which the cameras can capture is cut down by about half. So these are our Prime 41 cameras that we're using. So we have two cameras, Prime 41 and Prime 17, 4.1 and 1.7 megapixel camera that have an adjustable aperture on the lens. So we can cut down the amount of light coming back to the camera. And so closing the aperture on the lens of the camera helps to get rid of some of that extraneous sunlight. So like I said, the more controlled the environment, the better. So like this is not the most ideal thing where you're shooting on the top of a mountain, shooting directly up into the sky. The sun can get in the way. So indoors is always better. So our Prime 41 cameras can see 100 feet away to a 3/4 inch marker indoors. These ones, because they're such a massive field of view, these are the Prime 13W. They have an 82 by 70 degree field of view. So they can see about 20 feet away. Our Prime 13s can see about 40 feet away. The Prime 17s about 50 feet away. This is an interesting application. This is a guy, Sam Schmidt, who is quadriplegic. He was an Indy race car driver. And he was in a wreck and lost the use of his body pretty much. So this company called Ball Aerospace, which is in Ohio, made a project to help him to be able to drive again. So we put markers on a hat, had markers mounted in a Corvette. So he, this past year, got to drive one of the Indy pace cars during the race, and which is kind of cool. So he was able to, steer the car by the use of his head, and he had a thing that he could bite down on to brake the car. Oh, this is that. Maybe I don't have audio on this. Yeah, I don't have audio on this one. But this is one where they're flying the quad rotors and playing a song. And then that other one, I think, let's see. This is game on audio for Batman Arkham Asylum or Arkham Origins. So you can see the different moves. Obviously, that performer did not do that ridiculous move that you saw. So it may have been like a combination of a couple of moves as she moves around Batman's body. But I mean, you can see the speed at which she does it, right? So you can do these moves and then speed them up and slow them down in post-processing to add to the effect of what you're trying to capture. So it's, again, just a way to be able to have more control over the animation data as well. And then one other thing, I don't know if you guys saw this Bud Light commercial where they, this was on during the Super Bowl, where they had this guy do this live Pac-Man game. They just picked him up from a bar and took him to this location. So this is another customer of ours who did all the tech for this. Right, so the guy comes in and walks around and has to do, let me see if I can find the part of it where he's actually running around. So this customer VYV, or Blacktrack, sorry. Let's see. I know there's a shot where he's like running around. There you go. So right, he's running around the space, trying to get away from the the Pac-Man ghosts. Another art technology mix, which is kind of cool. So Blacktracks does a similar technology where they're tracking like an LED on a person, and then wherever they go on that Pac-Man path, they'll know, oh, he went over this section, so get rid of the floor marks. Let's see if I can find an overhead on that. Maybe it makes more sense like that. Right, so as he goes along, the dots on the floor that Pac-Man goes over disappear. And I don't know, it's kind of cool. Anyway, anybody have any other questions?
I think we're just about time.
Yeah. Yeah, thanks for stopping by. Appreciate it. If you guys have any other questions, feel free to ask. I'm happy to help.
Okay, just another note. NaturalPoint and the college have a teaming agreement, and so we have a set of cameras provided by NaturalPoint in the virtual production lab located on 3rd floor of Harbor Walk East. So if any of y'all are interested in doing anything related to motion tracking or capture, just come on by and let me know. I'm Dr. Barres. I coordinate that lab, and we have Brent Mason just located across the bridge from us, and local expert indeed. So we'll probably be hearing from Brent again in the future. So thank you for coming.
Thanks, guys.